About a week ago, I wasn't recording my voice, so students were saying, "Hey, there's no, can't listen to you talk," and that's probably a good thing. But anyway, here we go. So, what we're going to do is, well, let's do this. Solving. Here's our topic: solving systems of equations. I'll call them linear equations because that's pretty much what we're going to do. Okay, so solving a system of linear equations that's what we're going to talk about today. All right, and there are 4 ways to solve a system of linear equations. You're going to see 3 of them, and you get to see all 3 of them today. You probably won't see the 4th one unless you take a little bit more mathematics. So in solving any type of problem, whether it be the linear equations that you did in Math 60, or as you progress on to quadratics in this course, or even higher problems, graphing is always an option. And in some cases, graphing is the only option to use, because some things, the only way you can really solve them is by graphing. It's just way more convenient to do it that way, rather than to do it like at a paper, pencil, algebraic way. Another method that we're going to talk about is called substitution. Okay? And substitution is a good method in certain situations. Some people like substitution. I always kind of found it to be okay. I think the next one we're going to do and graphing are better. The last one's just called elimination. Elimination will work on just about every system of linear equations. It works great. So it would be the method of preference. However, some people again think substitution is better. So again, it's kind of up to you. I am probably not going to be really a stickler. So on a first test, my problems would be something like solve this system of equations, okay, and then I might have you do, say, I don't know, 8 of them, all right, and I'd say do 1 by substitution, do 1 by elimination, do 1 by graphing, and then pick any way you want for the rest of them, okay? So it's not like I want you to know how to do every single one of them very, very well. I think whenever you have something to figure out to solve a problem, you know how to do it, you pick your best way that you know how to do it. You know, why would you pick a way that you're not too familiar with? So that always made sense to me. So that's kind of how I envision. So what we'll do as we go on, I'm going to say, this is what my test question or quiz question is going to look like. So then you'll know. So let's talk about graphing. So I'm going to give you a system here. I'm just going to say solve this. So let's just start out with something like this. Okay, that's a system of equations because there's 2 of them. So there's 2 equations and 2 unknowns. Those are the 2 variables, x and y. All right. You could have as many as 10 equations and 10 unknowns. I saw somebody doing one like that. All right. So that's also called a system. 3 by 3 would be 3 equations with 3 unknowns. But this is just 2 equations with 2 unknowns. All right. So 3 by 3s are somewhat common, again, as you take more mathematics. All right. Some of these have some applications which we'll take a look at a little bit today, more so next week. But that's a system right there. So we're going to graph it. And I'm going to graph it by hand, and then I want to show you how to graph it using some technology, so you'll be able to see it both ways. Now, in order to graph this, we have to solve it and set it equal to y. All right? Now, I'm going to go through this, and I'm going to be interested to see how you've been taught to graph these, because sometimes I get different ideas. So for me to solve this and to graph it, I'm going to solve it for y. So if I'm going to solve for y, I'm going to move that x over. So I'm going to subtract x from both sides. I'm going to get y equals 4 minus x there. I'm going to go like this. I'm going to get y equals, and I'm going to add 2x to this side. So I get, oh, here, let me rewrite this one because you probably won't like that form too much. Negative x plus 4. There we go. Add this one, 2x minus 6. Now they are in a form that I can graph them because I'm solving for y. Is that familiar to you? Okay. If there's something you're not sure about, say, hey, I'm not sure about that. Right, and I'll be happy to go over it. So now, I'm doing this by hand because this is what PCC Math wants me to be able to do. So I'm going to make a little graph chart here. Okay, some people like to get graph paper, you know, and use rulers. If you want to use graph paper, that's fine. Don't worry about making real straight lines, because if we wanted real straight lines, we'd use technology. All right, so here we go. So we're going to graph this. So I'm going to pick red to graph this line, and we'll pick green to graph this line. So let's see what we know about this y equals negative x plus 4. Okay, so what does this number out in front here represent? 1 what? What is it? Yeah, I know that, but I still haven't heard what I was hoping on to hear. What does this number represent?
The x-axis.
What is it? It's the slope, right? That guy's the slope. Okay, what does this represent? Y-intercept. You can use the y-intercept and slope to graph any line, correct? Good, because that's important that you know how to do that. So we're going to go up 4. That's my y-intercept right there. Up 4. And then what's my slope? What's the definition of slope? Rise over run, right? So what's my rise in this case? Negative 1. What's the run? Positive 1. Okay, so we're going to go down 1 over 1. There's my line right there. Okay? So I'm using y-intercept form to graph this line, or slope-intercept form, sorry. Slope-intercept form to graph this. So here's my slope. Here's my intercept. 1 up to 4, down 1 over 1. Okay, look, I didn't even go through those points, right? All right, so there it is. Okay, now I'm going to do the next one. So what's my slope on the next one? Positive 2 is the slope. That's a number in front of the x. Right there. There's my slope. What's my y-intercept? Negative 6. So I'm going to go down to 6. Negative 6. 1, 2, 3, 4, 5, 6. Right there. Slope is rise over run. So that means I'm going to go up 2 over 1. There it is. Graph my line. Okay? All right. Now, this system of equations, what we're looking for is we're trying to figure out where they're equal. Okay? We want to know when they are exactly the same. Well, looking at this graph, I don't want to really know a point or anything, but where are they going to be exactly the same? Where they cross. So right there. See? Now, I make this stuff up, so all my answers are always going to be some kind of a weird decimal or something, because I'm just making stuff up. In the book, though, they plan it out because it takes them years to write a book, so they get everything pretty well right. Let's see, this intersection point. I don't know what's right there. I'm going to take a guess as to what it might be. Let's see, 2.2, I guess, maybe, and 1/2. See, I don't even know what it is, okay? But I'll take a guess at it. same thing for you. So when you're sketching them out, if it looks like it crosses and they meet together at about here, if you'd have told me it was 2 and 1, I probably wouldn't have marked it wrong. All right, because you're within the ballpark. Okay, if you want it to be accurate, then we'll use technology. But for this, it's just a sketch. Okay, so I'm not going to get too excited if you say, I think it's 2-1. Okay, maybe it is 2-1. I don't know. That's close enough. If you say it's -2, -1, then I'm probably going to mark that wrong. But as long as you're in the ballpark, it's okay. So we just solved our first little system of equations by graphing. And that's the kind of thing that they're going to want you to do by hand without a calculator or technology. Okay, they're going to want you to be able to graph a line and look at the intersection and say, here's what it is. Okay? And it's really good if you can put them into solving for y, all right, and you can recognize that's the slope and that's your y-intercept, and then you can graph it from there, you're great. That's important. That's what you should be able to do. I'm really kind of curious, so is everybody pretty familiar with using slope and y-intercept to graph? All right. Because I taught a 65 class before, and a couple people said no.
I think so far the graphing is the hardest for me. Simplifying and stuff is not, but somehow like my dots, I don't, so.
That's why people say this is, remember I said that this is the challenging part, and a lot of it is with the graphing. Okay, yeah, that's what they say. All right, let's try some more here. So, turn this down a little bit. So let's start off with another system. All right, sometimes they're already in the y equals form. Okay, but I like to kind of not have them in y equals form, because then you got to manipulate them a little bit. So let's start off with this one here. We'll do another one like that, and then we'll do another one here. Okay. So again, we have another system of equations, a linear system. All right, we're going to graph it. Okay. Yeah, that's better. All right. So if this is something that I would have to do, I'm going to graph it. So in order to graph it, what do we have to do first? What is our first solve for y, right? We got to solve for y. And when we solve for y, what are we always moving? X. Yeah. If you're going to solve for y, you're always going to move x. Okay? So if we're going to move x, how are we going to move this? Well, yeah, so we're going to subtract 2x from both sides here. All right? So y equals negative 2x plus 8. All right? Okay, so that one's done. How about that? Now we got to do the next one. So if we're going to solve for y in the next one, we're going to move the 3x. Good. And we're going to add it. All right. So now I have 2y is equal to 3x minus 6. And then what do we do? Because we have a 2y, we don't want 2y, we want y. So we're going to divide everything by 2. All right. So here's my two equations. I got this one here from the beginning, the first equation. And now I have this one here, which is my second one. All right. Now, I don't think there's anything wrong with writing it like that. Okay, where you just leave both of these numbers over 2. All right. And if you could figure out that this is the slope and this is the y-intercept, then you can just leave it like that. Okay. But I broke it down because I'm not exactly sure where you are at. But a lot of times I might just leave it as 3x minus 6 all over 2. And then we can just figure it out from there. Okay. let's see. Let's do, this one's a little lighter green. I'll do this one in black down here. Make another graph. Oof. Sometimes this thing kind of connects things if I don't lift it up good enough. Okay, so we're going to do this one in green. So what's the slope of the one that I'm going to do in green there? I guess you can tell the difference. The slope of the top one is -2. Y-intercept is 8. So see, I didn't even leave myself enough room to do this. So let's see, 1, 2, 3, 4, 5, 6, 7. I'll put 8 right about there. And then I'm going to do what from there with my slope? Down, over, 1. So see, I'm just kind of approximating a lot of this because it's just a sketch. There we go. All right, now I'm going to do this next one in black. I got 3 halves and -3. So where do I start at? -3. What are we going to do from there? Up 3 over 2. Okay. So there's my sketch. All right, now, hey, this was not too bad. What's the intersection point there? 3 and 2. It looks like it's about 3 and 2. Okay. It's always going to be where they cross. That's the intersection. Where they meet.
So do we go, the y is -3, we go up 2 and run 3? Or do we go up 3 and then run 2?
We up 3. It's rise over run, right? So up 3, run 2. Okay, let's see if I can get this working here. Oh, good deal. Oh, all right, here we go. Okay, I want to show you how to do this with some technology, but I'm going to have to switch to this. Maybe. Why isn't it? There's a blank screen. Come on. Show me the... I can't access the internet on my tablet. I don't know why. Maybe I just have to disconnect it. Okay, we'll just disconnect it.
Are you connected to the internet?
I am now. Okay, so try this out on your phones here. So we're going to go to open up an internet browser, and there's an app for this. And I've never used the app myself. I've always just used the online version. Other people use the app, and we were talking about it just this week, actually. Couldn't find any difference between the two of them. So it's up to you. The site you want to go to is DESMOS, Desmos, that's what it's called. DESMOS, Desmos, DESMOS. And when you do that, you'll see beautiful free math. Can't beat that. Graphing calculator, click on whatever one you want. Or choose whatever one you want. And that's what you get when it pulls up. Okay? So, again, there's the app. It's free. You can pull it down. It looks the same way. All right. Nice little window for graphing. I think the phone version is a little different. Okay, here's where your X's and Y's are, parentheses, everything else you need to use. If you go over here to where the little plus is, that's where you're going to add stuff to this. So if I click, on that, I get some options. I'm going to do an expression. And I'm just going to type it in. So let's go ahead and type in the one we just did. So I'm going to go y equals minus, because they treat negatives and minus the same, minus 2x plus 8. Okay, so there it is. Graphs it for us automatically. Now I'm just going to pop down here to 3. Well, mine's 3. Yours could be 2. And I'm going to change, or I'm going to write the same thing. This time the other one, y equals 3. Fraction is going to be a division, so I hit division. 2 pops down there and puts the division there. Okay. The one thing you want to be careful of is that it still thinks it's on the bottom. So if you put an X now, it's probably going to pop down there. So you might have to either, hit with your finger or use the arrow. Where's the arrows? Here they are. And make sure that X does not pop down there on the bottom. Minus 3. Okay, so there's our 2 lines. All right. And what point are we interested in?
Where they meet.
Yeah, and if you go tap on it, it tells you what it is. 3.14 and 1.7. Now that's pretty slick. Okay? That's pretty slick right there. So, one of the things you'll have on your quizzes and tests is, I'm going to say, hey, solve this system of equations by one of those other methods and verify your answer by graphing. Because it's so easy to just type this in the Desmos and graph it and check to see if you're right. So if you don't get this point, then most likely you've made a mistake someplace in the other methods, maybe with a negative or you subtracted wrong or something like that. I mean, it's quite possibly that these were entered incorrectly, but I say about 90% of the time the mistake is a non-graphing mistake. So you can say, hey, my answer is not correct. I need to review my work and see maybe what I did wrong. If you can't find it, then you write me a little message, say, I know my answer is not right, can't find my mistake. Because then you're telling me that you understand there's a mistake and you can't find it. Okay? And that, to me, that's pretty powerful that you can recognize that. So that's how you use it. Was everybody able to do that?
Yep.
You can't get it to work? Huh?
I can't get internet on my phone.
Oh, really?
This is not a private connection, so it just doesn't let me do anything with it.
Oh, okay.
But I'll have a graphing calculator next time.
Okay. As long as you have something, right?
Yeah.
Would the app work, you think, if you downloaded
I
that?
tried downloading the app, and I couldn't get down to the Google store to download it.
Okay. But if you downloaded it outside and then brought it in, would be maybe okay?
Probably.
Yeah. You could try that. Okay. All right. Cool. So I'm going to just leave that, minimize that. Now I'm going to go back to this thing. Okay. I don't know why this won't let me pop back and forth, but anyway.
I don't know what the passcode. I got my own passcode, so I'm just doing the online.
Is there any questions on the graphing part, what we just did there?
This is like the most amazing thing. Wow!
All right. It was worth your money right there, huh?
Yeah.
Okay. Good. Yeah, it is an amazing thing. And it's free. That's what's really amazing. All right. Let's see. Just trying to... And again, I want to give you some of these to work on anyway during class. So if you have any questions, you can always ask me then. I'm just looking to see if there's anything here that's going to mess us up. I don't see anything there. Most of them are already solved for y for you. And we did a fraction one, so we're okay there. All right, let's do a little bit of 4-2, and then I'll give you a break here. So the next method we'll take a look at here for a little bit, and then I'm going to give you a break, is substitution. Okay, so substitution method, again, it's not particularly ideal for everything because it's a little bit of work, but I'll show it to you, and then you can decide after we're done today, you know, do you like substitution, do you like elimination, you know, which one do you like? So let's talk about the whole concept behind it. All right, so let's say I have a system of equation, x plus 3y equals 12 and 2x plus y equals negative 8. Okay, so there is a system of equations. All right, and what we're trying to do is figure out where they cross. That's where they're equal. So the idea behind substitution is saying, well, why don't we take this equation, or this one, either one actually, solve it for one of the variables, and then replace it into the other equation. Okay, so we're taking one and substituting it into the other. By doing that, you're making essentially you're making things equal. You're forcing those two equations to be equal. So we're going to pick one of the variables in one of these equations and solve for it and substitute it into the other. When you do a substitution, I set this one up because it's pretty ideal for substitution. You definitely don't want to solve for this y, and you definitely don't want to solve for that x. How come?
Because they have the number, right?
Right, because they have a number. And then you would have to divide. And that would make a real mess. It creates fractions, and hardly anybody likes fractions. So let's not do it. So I'm going to pick this equation here, and what I'm going to do is I'm going to solve for this x. All right? So unlike what we were doing before with graphing, you can pick y or x. It doesn't make any difference. So I'm going to solve for that x, which means that we're going to move this y. So I'm going to move it over to the other side like this. So now I have x equals 12 minus 3y. There we are. So far, so good? So now, the idea behind substitution is we're going to take this equation, this expression, and put it in right there for the x in the other equation. We're forcing them to be equal when we do that. So now I'm going to take this and put it right there. That's what substitution's all about. So now I have 2, and we get 12 minus 3y, okay, plus a y equals negative 8. And when you do that, you've eliminated, or not eliminated, I guess, you've replaced the x with the y, so now you can just go ahead and solve it like a normal equation that you did a whole bunch of in Math 60. All right, because you did a ton of these. So now we're going to go ahead and distribute like this. And I'm going to keep solving this out. So I'm going to combine these terms right here. So we get a negative 5y, a negative 8. And I'm just going to keep working this out. And I told you that when I do things, I make them up, so they rarely work out to be anything nice. But of course, yours in the book probably will. In fact, if they don't, then I'd be concerned. So it looks like I'm going to get, let's see, 32/5. And I'm going to use a decimal because I don't want to deal with 32/5 as a fraction, but I will deal with a decimal anytime. So let's see, 6.4, I think you'll see that's going to be. Am I right? Anybody try it? Thanks. Okay. So, you did all this work, and you think, man, I got it. It's 6.4. Problem is, and this is where a lot of people forget, that the intersection is a point. It's an x and a y. So you only have the y, you don't have the x. So we have to go back and substitute again to get the x. All right? So I can substitute this 6.4 into any one of these y's that I want to. But it makes a heck of a lot more sense to put it into this equation, because then I can just use a calculator and say, hey, I want this calculator to take, let's see if I can find one here on my calculator here. Oh, there it is right there. So I'm going to go, let's see, 12 minus 3 times 6.4. And hopefully it's a scientific calculator. It's not a 4-function one. And see, I think that was definitely...
Is it negative 7.2?
Oops. Well, I can tell you it's not 180, which is what I got. Let's see, 12 minus 3 times... I think I didn't get 6.4. I think it said 64. 7.2, yep. So x is equal to negative 7.2. Now I have an x and a y, so the point would be negative 7.2, comma, 6.4. And the beauty of it is now, I would go, if this is me and I'm doing this next week on my quiz, or in a few weeks and I'm doing this on a test. So now what I'm going to do is I'm going to go into Desmos and I'm going to graph those equations and figure out where they cross. And if they cross at 7.2, 6.4, I got it right. Okay, so I'm going to do that. Oh, first though, I got to solve these for y. So I got to solve this one for y. What's this going to look like solved for y? Y equals, what would we do on that? This top one here. So we're solving this for y, so what do we got to move?
The x.
We move the x over, so that'd be...
Negative.
That's negative x plus 12, right? And then what would we have to do after that? Because that would give us 3y. So then we would have to divide by 3. Okay? All right, now I'm just going to leave it like that. Okay, now let's do this one. So I'm solving for y. So what do I got to move? 2x. So I move it over to the other side. What am I going to get? Negative 2x minus 8. Okay, so now I'm going to graph these. All right, hopefully I can remember them. So when I unplug this, because for some reason, the only way this thing's let me do this. There we go. And going to go into my Desmos down here. And I'm going to type these in. So I don't need these equations anymore, so I'm just going to delete them by hitting the little X. Go like that. Here's what I'm going to type in. Y equals. Now, this first equation that I did, okay, the negative x plus 12 all has to be divided by 3. So I'm going to put a parentheses, negative x plus 12, parentheses, divided by 3. So the whole thing is divided by 3. And what's nice is it shows it to you. You go, that's exactly what I want. So I want to leave that one alone. And then I'm going to go y equals, and put my other one in there, which was negative 2x minus 8. And, oh, I have a red one and an orange one. I can't see where they cross. So I'm going to do whatever this is called. I don't know what the proper term is for it. There's the negative 7.2 and 6.4. There it is. Okay, and it's nice because if you do that, it will zoom in and out. You can move your screen around real easily. There are times where that becomes kind of a pain, but for the most part, it works pretty good. So then our answer there justifies with the answer we got. We're happy, and there you go. That's how I would do it. So my test or quiz questions, that's kind of what they're going to look like. Solved by substitution, verified by graphing. Okay, that way I can kill two birds with one stone, so to speak. Questions on that part? Okay, I'm holding. And you can change the color, by the way. If you hold this down, you can change to whatever color you want. Well, 6 colors anyway. Okay. All right, so I said I'd give you a break, so go ahead. Take about 10 minutes or so. Come on back, hopefully. And we'll do some more after that. We'll do some more graphings. And okay, so I'm going to continue to go here. All right, so we just did an example of substitution, so let's do a few more. All right, before we move on to elimination. All right, so let's say we have one like this. Again, we're going to do these by substitution. So we need to pick a variable that we want to solve for, and we need to pick an equation we want to solve for that variable in. So which one would make sense in this case? Y, and then which equation?
The first one.
First one, this one. Okay. We could do this, but then we have a negative x, so if we have a negative we'd have to deal with. So it makes sense to solve for y in the top one. Okay, so that's going to mean, that means we're going to get y equals, what's that going to look like?
Negative 2x plus 10.
Okay, negative 2x plus 10. So now that I have that, what are we going to do with this negative 2x plus 10? It's going to substitute in for y right down there. Okay. All right, so then we're going to have a negative x plus 3 times negative 2x plus 10 equals negative 6, like that. And now we just go ahead and work it out. Okay? So let's see, negative 7x plus 30, negative 6, and we just keep, like I said, you've done a lot of these, so and here we get another decimal. No thanks. Okay, let's see. 36 divided by 7. Oh man, that's nasty. 5.14. So I'll just take it to a hundredths. 5.14. So everybody else got that too? All right. So there's my x. So again, you've done quite a bit of work, but we're not done because we need a point. So what do we have to do with this 5.14? Yeah, we got to plug that back in. The easiest place to plug it in would be right up to here and here, because that one's already solved for y. Although you could pick any of the other equations, it doesn't make any difference. You're going to get the same answer. It's just easier. So let's see, I had y equals negative 2x plus 10. Y equals negative 2 times 5.14 plus 10. .8 or 2.8, I guess. So my answer should be 5.14, comma, negative 0.28. And again, you can check it. Now, in your assignment, let me see if they ask you to do that. Writing system by substitution method, there's no solution. No, so far you're good there. Sometimes they want you to check it by back substituting it in, but they don't. This one, so that's good. Okay. And we could check it by graphing it, but I want to forego that for. I just want to get you onto the substitution stuff here. All right. So let's just do one more if we're going to measure here.
I'm sorry, can you go up a little bit?
Sure. No problem. Whatever you need. So we're good? Okay. All right. So let's do another one here. Let's do 2x plus 4y equals 12 x minus y equals negative 8. Okay. So this one here makes it real obvious which one we're going to solve for. So which variable are we going to solve for and which equation?
The x in the bottom.
X in the bottom one, right? Okay, because it doesn't make any sense to do it for any other ones. We're going to have to do some division. So I'm just going to add the 3y over here, add the 3y here. Okay, so there's what I got. And what are we going to do with the 8 plus 3y? We're going to put that into there. Okay, we always take the equation that we solved for, put it into the other one. All right, so we're going to get 2 negative 8 3y plus 4y equals 12. And now we just work this out. I'm writing out kind of a lot of these steps, so you wouldn't necessarily. You could show, as far as that showing work goes, you know, I'm going to try to give you partial credit when I can. So on a test and a quiz, you want to show steps so that I can see what you did, and if I can find your mistake, then I can give you a lot more points than if it's a, you know, than I can if I can't. But on assignments and stuff, you just use your judgment as to what you want to show. So that's just kind of a right or wrong thing. $2.8, does that sound right? Yeah, good, okay. And again, man, we're feeling pretty good because we got this far. But again, we need a point, so we got to substitute or plug that back in to this equation up here. Junk out of here. So I think I gotta go 8 negative. Nope. Clear. Negative 8. No. Oh, there it is. Clear. 8 negative plus 3 times 2.8 equals 0.4. I got. So my answer 0.4 2.8. And we can graph that to justify our answer, but again, I've already showed you how to do that, so. And we'll do some more a little later. So, questions on substitution in that method? Okay. So, the last method I'm going to show you today, we'll do some of those, and then I'm going to give you a chance to do some of your assignments. So, let's take a look at that one. And that one's called elimination. And elimination is good to use Sorry. Elimination is good to use when, here in this case, substitution isn't very good because we don't have anything that doesn't have a number by it, okay? So using using substitution isn't very nice. It just doesn't work out as well. So elimination is what we're going to use. The whole idea behind that is to take these two equations and perform operations on them to eliminate a variable. So that's why it's called elimination, because you want to eliminate one of the variables. Okay, that's the whole idea. So we want to get rid of it. We can do that by performing operations on these equations. So what do I mean by that? Well, let's say that we want to get rid of, so we're going to eliminate y, for example. Okay, this is an equals here. So I'm going to eliminate my y's. To do that, I'm going to multiply the top equation by 2. And what happens is when I multiply the top equation by 2 is these numbers are all going to change. But this one, most importantly, is becoming a 6. So I have a 6 here and a negative 6 here. So when I add those equations, the y is going to go away.
Can I ask a question? What will we always use 2?
No. Why did we use 2?
So that way you can subtract the y?
That's right, because 2 times 3 is going to give me 6. Okay? So that's why I said, hey, I want to use 2 here. Okay?
If the y, for example, was just say 18, then we would do that times 9 or whatever.
Yeah, whatever is going to eliminate it. All right? So for right now, I'm going to multiply by 2. So now I a 4 here, and a 6 here, and a 12 here. Now, you might say, how can you do that and get it to work? Well, because you're not changing that equation at all. When you multiply this equation by a number, you're not changing it. It's the same equation, it's just bigger. Right? So as long as you multiply by some number, the equation doesn't change. Okay? It's just you're making the numbers bigger. Right? But it's like taking a fraction, and you know how you reduce a fraction? Well, if you multiplied it by some number, you're just making it larger. But the fraction doesn't change its value. Okay? It just becomes not reduced. All right. So now I'm going to go ahead and I'm going to add these equations. And so I'm going to focus on this one here, okay, and this one here, because I just changed that other one. All right, here we go. So 4 and 4, that gives me 8. The positive 6 and the negative 6 are going to go away, and I get 15. 12 plus 3. So I add the equations. Now look, I can divide by 8. I get 1 point, let's see, 875 I think it is. I'm just going to round it to 1.88. And now I know what x is. So much simpler than substitution, where I had to do some solving and put it back in and do some algebra to get it. I got an answer right now. It didn't have to do a whole lot of work. The problem is I still got to find that y, okay, and it's not as easy to substitute it back in and get it, okay. But I do have 3 equations I can choose from. I can put this into any one of these equations because it doesn't make any difference. They're all, these two are the same, and I can pick this one if I want to. Okay, so it really doesn't matter where you put it. I'm going to pick this 2x plus 3y one because the numbers are a little simpler, I think. So this 1.88 is going to drop down into there because it's x. Two times 1.88, 3.76 plus 3y equals 6. And now I just got to figure out what y is. Okay, so again, we're just solving these, which I know you did a lot of. Oops. 2.24 divided by 3. Y equals 0.74. So here's my point. 1.88 and 0.74. Oop. So another good comment would be, so when we're answering these, what is it that I'm looking for? Well, if you have x equals 1.88 on your paper and y equals 0.74 on your paper, I'm okay with that. It's good if you write it as a point because that's what it is. But, you know, I'm not going to mark it wrong if you just forget to do that, or, you know, it's late Friday night and you're trying to get it done, and I understand that. So, okay. That's how you do elimination. You're picking a variable, you're eliminating it, and then plugging it back in and solving. All right, so let's look at some more elimination ones. So let's go with 4x plus 5y equals 20, and then we'll go 8x plus a y equals negative 8. All right, so now we have this one. Okay, so let's talk about this one. Really, we can pick any variable here we want to eliminate. It doesn't make any difference. All right? So let's just say we chose x. So if I choose to eliminate x, what would I multiply this top equation by right here to do that? Negative 2. Why would I choose negative 2? Okay. Now, that's great because there's a couple things you said there. One, I'm going to multiply this by negative 2 because if I add these equations, those are going to cancel out. That's good. You can subtract equations. You just don't have to add them. However, multiplying by a negative and then adding is better for you as far as not making mistakes. So I would say to do that idea of multiplying by negative 2. Okay? However, what if we chose y in this equation? What would we multiply this one by? What would we multiply the bottom one by? Negative 5. For the same reason. Then those 5 y's are going to cancel out. Okay? So you can pick either equation and you can pick any variable, it doesn't make any difference. You're going to get there. It's just different paths. All right, let's go with that first idea. So we're going to multiply this by -2. So I get a -8, I get a -10, and I get a -20. Oh, not -20. I was just going to say, make sure that you multiply the whole equation by that number, or else you're going to just make the same mistake I almost did there. Okay, it's got to go all the way across, or else you're changing the equation, changing the problem, and then it's not going to work. Okay, here we go. So now I'm going to add -8 and 8, gone. -10 and 1 gives me -9y. -40 and -8 gives me -48. Divide. And let's see. 48. I told you none of mine ever work out. So if you get decimals from stuff that I wrote, you go, well, that's just because none of his stuff works out. But real life, you hardly ever get real nice answers anyway. So 5.3 repeating. Now I got to find x. Okay. I got 3 equations to choose from. Maybe I'll pick this one, only because, I don't know, has a y by itself. So 8x plus 5.3 repeating equals -8. Going to subtract this 5.3 repeating. -13.3 repeating. Divide by 8, divide by 8. Take my calculator. And I can go 13.33333, throw a few 3's in there to get an accurate answer. 1.6. Negative. So my answer, -1.6 repeating, 5.3 repeating. There it is. All right. Okay, I want to do one more elimination problem. Then I want to examine 3 other, well, it's actually 2 other ones before I turn you loose on some stuff, okay? So, let's do one more elimination problem. This time, I'm going to make it look like this. I better be careful with this one here. There we go. Well, there we go. So, huh? Oh, sure. Yeah. Yeah, if you need to slow me down, don't be afraid to slow me down. Hey, just tell me, because I don't know. All right. So now we have this. So here is no real clear cut when we're going to multiply by. So, oh, I guess there's one thing. Which one should we eliminate? Okay. That's the y. X. Does anybody think y would be easy? I would y be easy. Because this one is, and this one is. So it's not wrong to pick x, all right? But if I pick the y's to eliminate, then I don't have to multiply by a negative, okay? Because they're already opposite, you know. But it's all preference. You got to decide which way it works for you. So maybe you just want to eliminate x in every single problem. You know, it doesn't make any difference. But I'm going to go with the y's. So if I'm going to eliminate the y's, I got to multiply both equations this time. Even if I pick that, because I'd have to multiply both equations. So I got to multiply both equations this time. And I could get fancy and figure out that lowest common multiple. Shoot, I'm just going to multiply this one by 6 and this one by 4. Okay? I mean, you can find that lowest common multiple, but, you know, what the heck. We just want to get through these, so let's just do it 6 and 4. Sure. Yeah, unlike, see, these ones up here, you know, we could just pick one of them to eliminate the x because the other one was 8. We were good there. Same thing with the one up here. We could just multiply since we had 2 and 4. But in this case, I can't, I mean, I could multiply 2 by 1.5 to get 3. You know, we want to do that. So, you can multiply the equations by anything you want, as long as you get it to work. So this time, I'm going to get 18 and 24 and 120. And this is going to be 8. And this is going to be negative 24. And this is going to be 24. Or no, 48, sorry. 48. Okay, and I'm not going to worry about big numbers because I got calculators. Shoot, I can even use a calculator on my phone if I want. Alright. So now I'm going to add these because the negative 24 is going to cancel. So this is going to give me 26x. Y's are gone. And then it's going to give me 168. Ooh, this is going to be a good one. There we go. 168 divided by 26. Oh, it is. X equals 6.46. I'm just going to kind of go like that. So again, what we're doing, I could multiply these equations. I could multiply this one by 1.5. I could multiply this by 1.5. But it's going to be a mess. So we could have multiplied by 2 and 3 here, made one of them negative and eliminated the x's. Could have did that. There's lots of different ways to go. You're going to get there. You're going to get there. It's just different paths. So we got this. Now let's go. Now I have 4 equations I can choose from to put this x into. Does anybody have a preference? Which one should we use? Yeah, I like that one too. So let's put it in for this one right here. I think that's going to be our best option. So I'm going to go 2, 6.46 minus 6y equals 12. 2 times 6.46 equals 12.92 minus 6y equals 12. And then I just got to figure this out. So y is equal to 0.15 positive. So there's my point. And the good news is I would be, graphing these with Desmos and checking to see, hey, can you imagine graphing these by hand, trying to find these decimal points? Oh my goodness. It'd be awful. All right, that's why we have technology, though. It makes, the ones you would do by hand with no calculator, I would make sure they come out to be pretty decent. I mean, again, I'm not trying to take points away from people. I just want to make sure you can graph something by hand. Okay.
So I had a question. So if we use that 3x plus 4, 6 equals 20, would that still come out to the same 6.15 as well?
It should.
Oh,
yeah.
It doesn't matter?
No, it does not. You can pick any of those equations you want. All right, questions on elimination? Okay, good. You're champs at all of it now because you're not asking me anything, so that must mean you're really good. All right. I'm going to stick with elimination for right now. Oops. Okay, here's my two equations. All right, I'm going to use elimination. Sure don't want to use substitution. All right, I'm going to use elimination. So, which one should we eliminate? X's or Y's? Y's? Okay, what equation are we going to multiply to do that? Top one by 3. Okay. Let's see what we get. 6x plus 12y equals 30. Okay, so what happens? Yeah, everything cancels out, huh? Yeah, x's and y's are gone. So we have a big 0 over here and a 22 over here. All right? So, something's weird's going on. Let's graph them and visualize what's happening. So I'm going to graph this one here and this one here. Okay? We're going to go into Desmos, we're going to graph them, and we're going to check to see what the heck is going on because I don't see anything that we did wrong there. And you know I set you up anyway. So, we're going to solve for y. So that means we got to move what? The x. So that's a negative 2x plus 10. I got to divide by 4. Okay, so there's one of my solve for y's. Here I got to solve for y, so I got to move x again. So I get a negative 12y there. Add a 6x. Oops. No, you need to put a plus. 6x minus 8. Divide by negative 12. So we're going to type these in, and we're going to check to see what happens. All right, I'm pretty interested in what happens. In fact, why don't you go ahead and do that. So we're going to go into Desmos. We're going to graph y equals negative 2x plus 10 divided by 4, and y equals 6x minus 8 divided by negative 12. See what happens. Hopefully they turn out okay. And we can see them. Remember, we're trying to figure out where they intersect. Anybody get it graphed yet? What's happening? They're parallel. They're not going to cross. Okay? So we're going to say this is a no solution because they do not cross. And if they don't cross, they don't have a solution. That's the whole idea. All right? No solution. So when you graph lines and they're parallel and they don't cross, they're not going to have a solution. All right? So it's possible for you to do these problems and do an elimination and get down here and get this. 0 equals 22. And you've seen this before in Math 60 where both sides of the equation, everything cancels out. And that was actually what your answer was. This is a false statement. 0 doesn't equal 22. So there's no solution. Okay? They don't have, there's no answer. No solution. All right, I'm going to set you up on another one. Okay? 3x minus 6y equals 12. And let's go with negative 12x plus 24y. Come on. Equals negative 36. Okay, pretty big numbers, two equations. Oops, not 36. What was I thinking? 48. All right. What are we going to multiply? What should we eliminate this time? What should we eliminate? X? What do you want to multiply which equation by to do that? Top one by 4. Okay, watch what happens here. 12, 24, 48. So what's going to happen now that in this situation? We're going to have 0 equals 0. Okay? So now this is even stranger than the other one. All right? So, again, I'm going to graph these in decimals. I want to see what's going on. So I'm going to visually graph these. I'm going to graph that. I'm going to graph that. And let me know what you find out. Yeah. When you graph these, they're going to graph right over the top of each other. I'm not exactly sure. I think it probably turns one color and then it turns to be another color. They go right on the top of each other. So the way you write this, you go x comma y. All right. This is kind of a little brace or bracket thing. Okay. Parentheses x comma y colon means such that, and then you pick an equation that you want to write. I'm going to pick this one. And what this means is that the solutions are all the points, x and y, such that it fits in that equation. Okay, so it's not every single point. A lot of people would say, well, it's all solutions, but it's not. It's only the points that are on that line. Okay, so that's how you show that. And you could have picked any equation that you want, but I just picked that one. Okay, so bottom line, you got one solution, no solutions, many solutions when you're doing these. So you got to check that out. Okay. They're having like a math fest or something out here. Great place to. They put our class here, and we're supposed to do some stuff, and then they, yeah. Very well. Sorry about that. Okay, so I'm going to pause this.